Now, what kind of a sequence is a geometric sequence? Actually, a geometric sequence in over the type of a sequence the constant ratio between the terms. Remember a ratio era a divide, and then difference era a minus. So this example give the arithmetic sequence. Arithmetic sequence the constant difference between the terms, meaning d is equals to t2 minus t1, which is equals to t3 minus t2. As you can see, t2 minus t1, 5 minus 3 is 2, and then t3 minus t2, which is 7 minus 5, and this is 2. So this number is constant because I change all the way. And then this is arithmetic sequence. But for a geometric sequence, remember the constant ratio between the terms. So the ratio denotes the letter R, which is equals to T2 divided by T1, which is equals to T3 divided by T2. So let's check already this ratio is constant indeed. This is term 1, term 2, and term 3. So T2 divided by T1 is 4 divided by 2. And then 4 divided by 2 is 2. T3 divided by T2 is 8 divided by 4. 8 divided by 4 is equals to 2. So this is true. This ratio is constant because this number is 1. And then even if we can try to find out the next term, or T4 divided by T3, we will get the same thing because the ratio is constant for a geometric. And then another thing, for a geometric sequence, moving from one term to another, multiply the constant ratio. So this means if we get the next term, we do 8 times 2, and then 8 times 2 of 16. So our multiply the constant ratio, and then our constant ratio in this case is 2. So finding the next term is 16 times 2, which is 32. So this is a geometric sequence. And then another thing about geometric sequence, we're going to the nth term formula. So I level that nth term formula. This is our nth term formula. So this nth term formula, reshumisha create any term here for the sequence. Let's say if questionnaire find a term number 10 or find a term number 100. So we do this formula, we create that term. Even if we find the term number 2 or term number 3, so we shumisha this formula to find any term for the sequence. And then this A is our term number 1. So this means if we shumisha this sequence, and then this means our A is going to be 2. And then R is the constant ratio, meaning R is equals to T2 divided by T1, or is equals to T3 divided by T2. So if we share this sequence, so this means our ratio is going to be 2 because it's T2 divided by T1 or T3 divided by T2. And then N give the number of terms, meaning if we find a term number 100. So this means for N it will be 100. And then if we find any term, so for N we substitute that number. So that's the idea behind the geometric sequence. And that's it for this tutorial. But now let's go over some practice problems for those questions in your test or in your exam. This is example number 1. Consider the geometric sequence. So this means this is a geometric variable. And then we'll fill our first 3 terms, 4, -2, and 1. So before answer any question, let's try to recap or re tseba eng ka the geometric. So geometric re tseba hore na le the constant ratio between the terms, and then again re tseba hore moving from one term to another re multiply ka the constant ratio. So now let's go to number A. Determine the next term of the sequence. But re tseba hore moving from one term to another re multiply ka the constant ratio. So this means ge re ka find the R, it will be easy to find the next term. So our R is equals to T2 divided by T1. T2 is equals to -2, and then T1 is 4. So this means our R is -12. Therefore, finding the next term is very easy because that's about moving from one term to another. Re multiply the constant ratio. So this means moving from 1 to the next term, we multiply 1 got the constant ratio, which is half. So this means our next term, which is T4. This means our T4 is equals to -half, because 1 times -half is half. Remember, this is term number 1, term number 2, and term number 3. So remove from term number 3 to term number 4, because questionnaire determine the next term. So the next term is term number 4. Now let's go to number B. Determine n if the nth term is 1/64. Because this is geometric, let's about the nth term, Tn is equals to AR to the power n minus 1. And then what really our nth term in this case, which is 1/64. So this is our nth term, 1/64. And then the value of n, remember. So this means we substitute A and R. And then our A is 4. And then our R is -half. And then from here, resolve the value of n. So moki it will the exponents. So if this is the case, R divided both sides ka 4, because R ka divide both sides ka 4, moki re tlo 1/256, which is equals to -1/2 to the exponent n minus 1. And then because this is exponent, so can I change 1/256 or able something like half, and then get like equator the exponent. So 1/256 in this way, -1/2 to the power 8, which is equals to -1/2 to the power n minus 1. And then now, because the base is that 1, so this means get to equator the exponents. This means 8 is equals to 9 minus 1. And then therefore, this means n is equals to 8 plus 1. This means our n is equals to 9. So that's it for this problem. This is example number 2. Given the sequence 4, x, and 32, determine the values of x if the sequence is geometric. So this is a geometric. Now let's rewrite our terms. This is 4, x, and 32. Banyaga the value of x. So to answer this question, it will be easy to that knowledge or the constant ratio between the terms, meaning R is equals to T2 divided by T1, which is equals to T3 divided by T2. So that knowledge, so this question it will be very easy. Remember, this is our term number 1, and this is term number 2, and this is term number 3. Now let's answer this question. T2 over T1 is equals to T3 over T2. T2 is x, and then T1 is 4, T3 is 32, and then from here we're going to cross multiply, or we're going to find out the value of x. So x times x is x squared, and then 4 times 32 is 128. And then now, because we got the value of x, so we're going to square up both sides. So we're going to square up both sides. This means our x is going to be plus or minus root 128. So this is our answer. There's no need to okay simplify. So I draw a line like the sub form, because 128 it's not a perfect square. So it's sharp in that way. So this is our answer anyway. This is our next example. The first 3 terms of a geometric sequence. So what fill the first 3 terms? 16, 4, and 1. Question error. Calculate the value of the 12th term. Leave your answer in a simplified exponential form. Let's rewrite our sequence. 16, 4, and 1. This is term number 1, term number 2, and term number 3. So, for a geometric sequence, moving from one term to another, we multiply the constant ratio. So this means if we have the next term, term number 4, we can multiply the constant ratio. And then we have term number 5, we multiply the constant ratio. So regarding in this way up until we reach the term number 12. But that one is a time consuming, because we have the nth term formula, remember. And then the nth term formula, we can create any term for the sequence. So I assume that nth term, Tn is equals to ar to the power n minus 1. And then we have term number 12, so T12, and then the value of a is 16. And then r is the constant ratio. R is equals to T2 divided by T1, or you can say T3 divided by T2, so it's the same thing. 4 divided by 16 is 1 over 4. And then this is term number 12. So this means for n, row substitute 12. Remember, n is the number of terms. So substitute 12. And therefore this is 16, 1 over 4 to the exponent 11. So this is our answer. Because question really, our answer must be in a simplified exponential form. So there is no need to press a calculator from this step. So this is our answer, and that's it for this problem. This is our last example. Question area. A geometric sequence has T3 is equals to 20 and T4 is equals to 40. Determine the common ratio, a formula for Tn. This question will fill only 2 things, term number 3 and term number 4. So unlike other questions, there are not things like term 1, term 2, 3, or even term number 4. So this question, it's tricky, but it's not that tricky, because I don't apply the same thing based on the geometric sequence. Now let's answer number A. Determine the common ratio. For a geometric sequence, the common ratio R, which is equals to T2 divided by T1, which is equals to T3 divided by T2, which is equals to T4 divided by T3, which is equals to T5 divided by T4, so on and so forth. So this doesn't mean or always stop more T3 divided by T2. So you can say T4 divided by T3, T5 divided by T4. So for this question, ke lemogile gore ke na le T4 and T3. So that is why ke decide T4 over T3. Because if R is equals to T2 divided by T1, ga ke na term number 2, and then ga ke na term number 1. If nka decide T3 divided by T2, ga ke na term number 2 either way. So that is why ke decide T4 over T3. Then to answer number A, R is equals to T4 over T3. And then T4 is 40. And then T3 it's 20. Therefore 40 divided by 20, it's 2. So this is the answer for number A. Our R is 2. Now let's go to number B. Determine a formula for Tn. That's about a geometric sequence. Tn is equals to AR to the exponent n minus 1. But o ka kgona lemoga gore this question ga rena A. And that's about always the nth term formula. It's only to be in terms of n only. Re ska ba le the two unknown variables. So re ka se be le unknown ya A, ra ba le unknown ya n. So this is nth term. The only unknown is only to be n, because n is the number of terms. So this means gore tlo tshwanela go create the value of A before tlo gonna find out the nth term formula. So finding the value of A, ke tlo substitute Tn ka 20, and then this is A, the value of R is 2. The reason ke substitute like a value of 20, this is because ke nyaka find out the value of A, because bar 20 is in term number 3. Ke a tseba Tn is specify a number. For example, term number 4 is 5. So this means my Tn is 5, and then n is 4, because n is the number of terms. So in this case, 20 is in term number 3. So this means for n, it will be a 3. And then from here, 20 is equals to A. 3 minus 1 is 2. And then this means 20 is equals to A. 2 squared is 4. Therefore, finding the value of A, divide both sides by 2. Therefore, A is equals to 5. But ukashumisha 40 again. So we will create the same thing. So let's try 40 to find the value of A. Tn is equals to AR to the exponent n minus 1. So Tn can be 40. And then A, remember. And then R is 2. And then because 40 is in term number 4, this means for n it will be a 4. 4 minus 1. Therefore 40 is equals to A, and then 2, 4 minus 1 is 3. Therefore 40 is equals to A, 2 to the exponent 3, it's 8. And therefore finding the value of A, I will divide both sides by 8. Therefore A is equals to 5. So it's the same thing. Now because I created the value of A, now we're going to the nth term. Tn is equals to AR to the exponent n minus 1. Therefore our A is 5. And then our R is 2. So n minus 1. So this is our nth term formula. Nth term formula always ever in terms of n. The unknown variables stay 2. So that is why I try to find the value of A. So anyway, that's it for this problem.